In this video, I'm going to be looking at polynomial and synthetic division. These are just basically ways that allow us to kind of take a factor out of a bigger polynomial. So if I know x plus 3 is a factor, I can divide it out of x squared plus, or x to the fourth plus 2x minus 3. It just helps us do this and simplify problems, and it just makes it easier to get your factors. So kind of with division, if we just think about like long division, say I want to do a really big problem, 501,000, that is not a 1. Try this again. 501,279, and say I'm going to divide it by 3. Well, if I want to do it by long division, on the inside would go the 501,279, and on the outside I would have 3. And then I would look at my first term here, my term on the outside, and my term right here, the first term, so that I know 3 goes into 5 one time, so I will write a 3, because 3 times 1 is 3. And then I'm going to subtract the 3 from what is right above it, and that'll give me 2. I'm going to pull down the 0. You can pull down all this other stuff if you want to, but it's just easier not to have to deal with it. Okay, and then I will see how many times 3 goes into 20. Well, 3 will go into 26 times, so we'll have 18. And again, I'll subtract it. So you're kind of seeing the pattern, right? Okay, I'm seeing how many times it goes into the first term, and whatever's left over becomes my remainder for this term. And then I'm going to see how much it goes into the next term when I pull down the next number, right? And so on and so forth. You guys know how to do long division. Polynomial and synthetic, well, really polynomial division is just like long division. Synthetic's kind of a weirdo, but we'll talk about them in a minute. Okay, with this division, you're going to see something like this. This is polynomial division. You can also use synthetic, but again, we'll talk about synthetic in a minute. Polynomial division, so I have this thing on top divided by the thing on bottom. So just like in your long division, whatever's on top is going to go on the inside, and whatever you have on bottom is your outside term. So your outside is going to be x minus 4. That's how you would set this up. If you guys are taking notes, make sure you're pausing the video so you can actually take the notes down. Okay, now what I usually do here is I tend to cover up this whatever is on the outside, so that I am just looking at my x term. There is 1x there, and on the inside I have 5x squared. Because you want to look at the first term. What is that? You want to look at the first term here. In order to get this x up to an x squared, I have to multiply it by x. So then x times x is x squared. Well, this is like 1x, so 1 times 5 will be 5x squared. So now I'm going to take whatever I have up here, multiply it by everything on the outside. So it'll be like 5x squared and then minus 20x for that term, just like I did in long division. Right, we had a 3 out there, so we multiplied it by whatever was up there, so it's just a number. This time I'm just multiplying it by the entire x minus 4 in order to get this next line. Now here's the tricky part. Whenever you get to your next line, didn't we subtract? So if I subtract, that changes signs, and then if I do minus negative 20, this becomes plus 20. So basically, whenever you do this line, all of your signs are going to change, whatever they are. So then 5x squared minus 5x squared is 0x squareds, and I'm left with 3x minus 12. Awesome. That's really what we wanted. We wanted these terms to go away. If they don't go away, try to go back and check something out. See if you can figure out what you need to multiply by in order to make these first terms at least go away. It's okay if these don't go away. They're not always going to, just like this. Okay, then for the next part, we want to figure out what I have to multiply this x by in order to make it 3x. Now we're looking down here. We want to get rid of this 3x. So x and x are already the same, so I don't need to multiply by any more x's, but I need to make this 1 into a 3. So if I multiply by a positive 3, then it's the same thing. So I'll have 3x. Don't forget to multiply the negative 4 as well, minus 12. And again, on this line, don't forget to change your signs. So negative 3x and plus 12. Well, that'll make 3x minus 3x is 0. Negative 12 plus 12 is 0. So we're left with a remainder of 0. Therefore, this whole thing divided out is 5x plus 3. And if you notice, this is the factors. We actually just found this. We factored this. This is x minus 4 times 5x minus 3. If you multiply this back out, you'll get back to the top equation. You can always check your work if you really want to that way. But this here is all I need to see for your final answer for ones like these. Looking at another example with you guys now. Again, if you're taking notes, you may want to go ahead and write this down. If you want to, if you're feeling more comfortable about it, give it a shot. See what you guys can figure out. So again, the thing on top is going to go on the inside. So x cubed minus 9. But here's the thing. We're missing some terms. We're missing an x squared term. So we need to put a placeholder for it. We're missing an x term. So I'm going to put a placeholder for it and minus 9. Just like in the long division problem earlier, when we didn't have a 10,000 spot, it was a 0. We had 501,279. Well, we can't just put 51,279. You have to have a placeholder. You have to have the 0 in that spot. So we have x cubed, x squared, x, and a constant term. How we're missing the x squared and x terms, you have to put a 0 in those spots. Okay, and then on the outside, you don't have to worry about putting a 0 out here. You can if you want to, but it's just going to take some more time to do the problem if you do that when you want to multiply out. So now again, just look at your first term. X squared, I want to see how many times it goes into x cubed. Well, it'll go in, and I need to multiply by x in order to make that happen, because x squared times x is x cubed. There's no coefficient on either of them, so that works out well. And then x times 1 is plus x. Don't forget, again, once you get to this line, you have to change signs. You have to subtract this entire line. So x cubed minus x cubed is 0. 0 minus negative x is negative x minus 9. And then x squared doesn't really go into x because it's a higher power, so I can't really do anything else. This is just my remainder. Well, when I have a remainder in long division, say if I had 20 divided by 3, that will be 6. If I put in 6, it'll be 18. I'll subtract, so I'll have a remainder of 2. So this is 6 and 2/3. Same thing with this division, with polynomial division. You will have whatever you are dividing it by, your remainder will be on top of that. So my remainder is negative x minus 9, so plus negative x minus 9 over what I'm dividing it by, so x squared plus 1. And there's your answer. Now I'm going to take a look at synthetic division. Notice this is synthetic division. You guys are going to absolutely love this. This makes life so much easier. Okay, synthetic division is a little bit weird. We have this big long thing. You can do it by polynomial division if you really like that. Or we also have this thing called synthetic division. It's kind of like an upside down division sign, where the numbers on the inside are still going to come from here, but I'm only going to use the coefficients. So 5 from the x cubed. I have an 18 from the 18x squared. I have a 7 from the 7x, and minus 6 from the negative 6 constant. Now here's the thing you have to be careful of. What we were dividing by is x plus 3, but you're going to use the 0 of x plus 3. So x equals negative 3. So on the outside, I'm just going to put negative 3. Now, always, 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 in order to do this, you start from left to right just as we would. You're going to bring down your 5, and then you are going to multiply by whatever you brought down by the negative 3. So this is negative 15. 18 minus 15 is 3. 3 times negative 3 is negative 9. 7 minus 9 is negative 2. Negative 3 times negative 2 is a positive 6. 6 minus 6 is 0. This last term right here is your remainder. Now, when you're actually writing your answer, since we divided an x cubed by an x to the first power, x cubed divided by x is x squared. So our first term now is going to be x squared. So here's your x squared term, this is your x, and this is now your constant. So in writing your answer, we'll actually have 5x squared plus 3x minus 2. There it is, synthetic division, way faster. I'm going to do this one by synthetic division again. just give you guys another example. So again, I'm going to make my kind of upside down division. So on the outside I have 6, on the inside I have the coefficients. So I have an x cubed, so I have 3, negative 16x squared, so minus 16. Well, look, I'm missing my x term, so again you have to put a placeholder, just like in long division. And then negative 72 is my constant term. Okay, 3 plus 0, I'm going to pull it down to 3, is 3. 6 times 3 is 18. Negative 16 plus 18 is 2. 2 times 6 is 12. 0 plus 12 is 12. 6 times 12 is 72. So again, I have a 0 remainder. So awesome. That's what we really wanted. I had a cubed. I divided out an x. So this will be my x squared term now. So to write my answer, I have 3x squared plus 2x plus 12. Bueno. He's the happiest monkey ever. It's raining bananas. Again, just using synthetic division. On the inside, we have our coefficients, negative 1, 2, negative 3, and 5. And then on the outside, I need to use the 0 of this guy, so I'm going to use negative 1. Now when I do it, negative 1 plus 0 is negative 1. Negative 1 times negative 1 is 1. 2 plus 1 is 3. Negative 1 and 3 make negative 3, so I'm at negative 6. Negative 6 times negative 1 is a positive 6. So, I have a remainder of 11. Okay, well, just like before, whenever you have a remainder, all you're going to do is just put it over what you're dividing by. So when you write your solution, we had cubed, we took out an x, so I'm going to be down to x squared as my first term. So I have a negative x squared, negative 1x squared. You can write the 1 if you want to, you don't have to, plus 3x minus 6 plus 11 over x plus 1. There it is. Synthetic division is also a brilliant invention because we can use it to evaluate the function. This is really, really simple to do without a calculator. So you guys probably aren't going to have a calculator for the test or quiz. So FYI, I forgot to tell you, no calculator, test or quiz that are going to be on synthetic division. Okay, so that means your quiz that you're going to have on Monday, well, not Monday for all the classes, right? Yeah. Okay. Or the test for this chapter. You're not going to have a calculator for some of synthetic and polynomial division, so make sure you guys know how to do this. Right? But again, I can use synthetic division to actually evaluate the function at f of 2. Don't forget, this is usually f of x, so this is my x. So I'm just going to put 2 on the outside. Then it's just your coefficients on the inside. I have 1x to the 6th. I'm missing an x to the 5th, so I need a placeholder. I have negative x to the 4th, missing an x to the 3rd, so I have a placeholder there. I have 3x squared, missing an x, and I have a constant 2. So it's just a matter of synthetic division. 1 plus 0 is 1, 1 times 2 is 2, 0 plus 2 is 2, 2 times 2 is 4, 4 minus 4 is 0, 2 times 0 is 0, 0 plus 0 is 0, 2 times 0 is 0, 3 plus 0 is 3, 2 times 3 is 6, 0 plus 6 is 6, 6 times 2 is 12, 2 plus 12 is 14. Whatever your remainder is, in this case it's 14, is what the function is at that point. So f of 2 is 14. Done! You could have plugged this thing in your calculator, you could have plugged in 2, okay? But a lot of the time, once you guys get used to synthetic division is going to be so much faster at this. Okay, another thing that you're going to have to do is show that a number is a solution. We have x equals negative 4 when this equation equals 0. So as long as we get our remainder as 0 when we do synthetic or polynomial division, doesn't matter which one you want to do, then this thing works out. This is true. So I'm going to go ahead and set up my synthetic division because I like it a lot better. I have 1x cubed, I have 0x squared, so I have negative 28 x's, and I have negative 48 as my constant. Now notice with this one, x equals negative 4, this is already solved for your 0, so negative 4 goes on the outside. Pull down your 1, 1 plus 0 is 1, negative 4 times 1 is negative 4, so I have negative 4 there, negative 4 and negative 4 makes 16, so I'm left with negative 12, 4 times negative 12 is going to be a positive 48, negative 48 plus 48 is 0, so I have a 0 remainder, which is exactly what it was supposed to equal. So then yeah, this thing checks out. Hopefully this was helpful. I will see you guys again in class soon. And make sure you ask friends a lot of problems. And yeah, that's all I got for you guys today. Thanks for watching.